What is currying? Currying is a way of turning a function which takes multiple arguments into a series of functions which each take a single argument and each return a single value. What is currying used for? First off, it's for defining functions with multiple arguments. It's one of the key ways of doing it in Haskell. Now, also, it can be used because by doing currying, you can create other useful functions from curried functions by partially applying those functions, those curried functions. I'll explain what that means later in the video. First off, let's have a look at the standard approach for defining functions with multiple arguments. In this example, I have an add function. If you have a look at the function type definition, it takes a pair of ints, which is a single argument, and it returns a single argument, which is just an integer. Now, it takes these two ints at the same time because it takes them in a pair. So if you look down for the function definition, it takes them as a pair and then it decomposes them and then does the necessary operations, which in this case is adding them, right? Crucially, functions can only take one argument and return one value in Haskell, which is why you have to do this workaround of using a pair, because you can't just take two arguments like you could in another programming language. So that's why you have to do it, okay? Now let's have a look at the curried approach. The curried approach for my cadd or curried add function that I've written, if you have a look at the type definition for it, this one seems to only take one argument. And that is the case because it takes one argument and it returns another function which then takes one argument. And then that function also returns a result. Okay, let's have a look, right? You can see it's got this x and y, right? And you can see it looks like it's taking them both at the same time. But what it's actually doing, like I've said, is it takes the x and then it returns another function which then takes the y, and then that function which was returned, which took the y, will then return the result. But it looks like it's taking both of them, and you can see it's doing the same operations. So I'll explain what the differences are, right? What are the differences? Well, first off, it's the function types, the function type definitions, right? With non-curried functions, they return a value. With curried functions, they return another function instead, which actually makes curried functions higher order functions, which I won't go on to in this video, but if you're interested, I will make another video, and that will be released sometime soon. Now, something that I want to point out is that on a compiler level, there really is nothing different between them, because all functions in Haskell are actually curried functions. It may not appear that way syntactically or with notation, because there's a bit of foolery, but under the hood, every function in Haskell is a curried function. Now, let's have a look a bit at some currying shorthand. First off with type definitions, the function type definitions, right? You can see this sum function, and you can see on line 19 with the curried add function, right? It takes two arguments and returns one result, and that's obvious, right? But when you have more than, as the more arguments it takes, right, you have to put more and more brackets in, and it can be a bit more, I guess, unwieldy, or you know what I mean, like it can be less simple or more cluttered. That's the word I'm looking for. It can look more cluttered. So what Haskell allows you to do is it allows you to remove the brackets and just make it look a bit cleaner. But basically what this sum function is it takes an argument, right, and then it returns a function, and that function takes an argument, i.e. this argument, right, and then that returns a function, this function, and then this function takes this argument, and then it returns this function which takes this argument, and finally the function which was returned here, right, this function here, it doesn't return another function, it just returns another argument. Well, in this case it's not an argument, it's now a value, it's the return value of the function. But you can see that here, right? With this you've got argument 1, argument 2, argument 3, argument 4, the return value. Okay. Let's have a look at the function application currying shorthand. Right. With function application, you will see things like sum a, b, c, d, which is for the same function, right? However, what that actually means is that first you do the sum of a, that returns a function, then in here, basically, this now becomes, I don't know, some function f, right? Now it's f of b, and f of b returns another function, g, and then it's g of c, and then g returns another function, h, and then it's h of d, and then it's just, I don't know, z, some return value z, right? And that's how the arrow works. So if I go back, as you can see, that's basically how it is. This is, again, this here on line 40 is just shorthand for what's on line 44 here, right? Now let's have a look at functions which are curried by default. What's this mean? What does this mean, right? Well, in Haskell, right, all functions are curried by default. As you can see, this is what it would look like in Haskell, but this is what it looks like in another programming language, in this case C. In Haskell, this isn't just some like fancy syntactical sugar styling guys. It actually has meaning once you understand that every function is curried in Haskell, because what it means is first the function is applied on A, then another function is returned, we'll call it F like I've just said, then that's applied on B, then another function is returned, we'll call it G, then that's applied, and then another function is returned, H, and then that's applied, and then finally a return value of Z is returned, right? That's what it means, right? Functions in Haskell, and this is important, functions in Haskell take one argument at a time, curried functions that is. They take one argument, they return a function, that takes one argument, that returns a function, that takes one argument, that returns a function, so on and so on, until you get to the point where you'll now have a function returned which just takes an argument and returns a result. And that's the result for the whole function. It's like a recursive sort of thing, right? In C, however, right, or most other programming languages, right, it takes all the arguments at the same time, because it takes A, B, C, D, and it takes all of them at the same time, and then returns a result. So that's the key difference between Haskell and other programming languages, like C. What does this mean? Well, it means that in Haskell, all function application goes left to right, and I've explained this a couple of times now, so I'm sure you understand what I mean. And that's important to keep in mind when you're writing functions and when you're looking at function evaluation, right? Now, I promised this earlier. Here it is, partial application of curried functions. What is that? Well, let's go back to the cadd, the curried add function that I wrote, and if we wanted to apply cadd 2 and 3, what that is, and you should hopefully get this by now, right, is that cadd of 2 and 3 is applied to 2 first, so you have this cadd of 2. This cadd of 2 is then another function by itself, right? At this point, right, the cadd function has been partially applied. It's not been fully applied, because if it was fully applied, you then take this function f, and then you take this 3, and then you return the result 5, right? That would be the full application of that function. However, the partial application of that function is when we just look at the cadd 2, and you can actually take that partial application and assign it to a new function. So as you can see here, right, this cadd 2, where you pass the x value being 2, right, you can assign that to another function, to this quote-unquote cadd underscore 2. This is a different function. Maybe be a confusing name now looking at it again. However, I hope it gets the point across. Now, as you can see, this cadd 2 is a different function. This is a whole new function, right? This function is the function which is returned by cadd when you pass it the x argument of 2. Now this cadd 2 function with the underscores, right, takes an integer and returns an integer. And the way you can think of it, right, is here, what it does is it basically substitutes the x value for 2. So with the regular cadd, right, regular cadd would look like this. This is what regular cadd would look like. Cadd 2 looks like this, where the x value is now replaced, it's sort of hard-coded with the 2 value, and that's how it works. I hope you've enjoyed this video. I hope this has been helpful for you if you've not looked at curried functions before. There's obviously a lot more to curried functions than what I've explained in this video, but I hope you've enjoyed it. If you did enjoy it, obviously subscribe and like and stuff, and stay tuned. I will be uploading more videos on Haskell. I'll be uploading videos on, higher order functions, probably a bit more on functional, partial function application, stuff like that. Stay tuned. I'm sure you'll like the videos I post soon. Thank you for watching.